Okay, so the next one is there are 4-point charges plus q, minus q, plus q and minus q placed at the corners A, B, C and D of a square side A. The potential energy of the system is 1 by 4 pi epsilon naught times what? You have to figure out. So you have to figure out the potential energy. Let me remind you, if you have attended lectures initially, okay, how to calculate potential energy. So to calculate potential energy of such a system, what we do is we start the whole system from the beginning. We will put our first charge here, and this first charge is plus q. This is first charge plus q. If this is plus q, what's the potential energy required to place this charge at point A? Sir, 0. So U1 is 0. Why? Because there is no other thing around this first charge to influence it. Okay, great. Now when you place the second charge at a separation of A, and this is negative charge, then the potential energy will be U2, that is equals to K Q1 Q2 upon the separation A. I hope this is clear. So from where you got this formula? This is there in the formula sheet, you can check. K Q1 Q2 upon R. The potential energy of a system of two charges is K Q1 Q2 by R, where R is what? The separation. Okay, great. Let's place our third charge to obtain our this configuration at point C. So when I am putting the third charge at C plus Q, listen very carefully. This third charge will be influenced by charge placed on A and charge placed on B. Let me repeat again. The charge which is placed at C is influenced by A and B. So what will be the potential energy to place C, charge at C? That will be K, the first charge, the second charge upon the separation. Now what's the separation between A and C? So let's calculate that. This is A, that is A, and this is a perfect square. So this will be using Pythagoras theorem root 2A. Now if you are asking me what is Pythagoras theorem, I'm really sorry. Okay. Let me repeat again. This AC you can find using Pythagoras theorem. So this will be root 2A. And what's the energy, potential energy between C and B? That will be K Q minus Q upon A. The separation between C and B. So I hope this is clear. U3 is the potential energy required to place the third charge at its position. Okay, great. Now what's the next one? D. What's this separation? A. What's this separation? A. And what's that separation? Root 2A. Be very careful when you are placing a charge, it is influenced by all other adjacent charges. So the potential energy to place the fourth charge at that point will be equals to K Q1. I am taking A and D first. So A is Q, D is minus Q, separation is A, plus K, A is, sorry, not A, B. B is minus Q, D is again minus Q, and separation is root 2A. And finally, the third one, that is K minus Q, this is D, plus Q, that is C upon the separation which is A. I hope this is clear. Now let's add all of them to get the total potential energy. So the total potential energy is U, that will be equals to U1 plus U2 plus U3 plus U4. So U1 is 0. Let's write here directly U2. So this is U2 minus KQ square by A, U3 plus KQ square by root 2A and minus KQ square by A, U4, that is minus KQ square by A plus KQ square by root 2A, and finally the last one is negative, yes, minus KQ square by A. I hope this is clear. Okay, so U will be equals to U1 plus U2 plus U3 plus U4. Next is what? Let's cancel whatever is getting cancelled. Okay, so nothing is getting cancelled. So this and this. Look at all these green ones. all of them have everything same. So minus kq square by a, I can call it as an apple. So 1 apple plus 1 apple plus 1 apple plus 1 apple. How many apples? 4 apples, kq square by a. Look at this one and this one, they are same. So 2 times kq square by root 2a. Let's take common out. So they are saying 1 by 4 pi epsilon naught times. So we can eliminate k. We can eliminate k because that already they are saying. So they have not expressed their answer in terms of k. So we can eliminate 1 by 4 pi epsilon naught. That's our k, right? What we left with? Let's see. So that will be minus 4 q square by a and plus 2 q square root 2. Let's cancel out 2 and root 2. Root 2 q square by a. So let's take common. What's common term? We can take common as here as q square by a, taking common, that will be minus 4 plus root 2. So that's our option A. You can verify that's our option A. I hope all of you understood this. Okay, so this is our